In 7.1, we'll be reviewing concepts that we learned in Unit 6, including factoring. So when we're factoring, the first thing we should always look for is the greatest common factor. So we're looking for what can all of the terms in the expression be divided by. So in this first example, 3x squared plus 9x, both terms are divisible by 3x. So your GCF is going to come out in front, and then you're going to divide each term by 3x. So 3x squared divided by 3x is x, and 9x divided by 3x is 3. And then you can always check it by multiplying it back together. If you were to distribute the 3x, you would have 3x times x is 3x squared, and 3x times 3 is 9x. On the next example, we're going to look at all three terms and see what all three terms are divisible by. So the numbers are all even, so they're divisible by 2. And the variables, they all have an x, and they all have at least y squared. So if I divide each term by 2xy squared, 4 divided by 2 is 2x squared divided by x is x, y squared divided by y squared is 1, so the y's are all pulled out, minus 6 divided by 2 is 3, x to the 5th divided by x is x to the 4th, y cubed divided by y squared is y, and then 12 divided by 2 is 6, the x got divided out, and y squared. And then again, you can check it by distributing the 2xy squared back in to make sure that it matches your original. Okay, another pattern that we've worked with a lot is a difference of squares. So a difference of squares means the expression must be a binomial. It has two terms, and the first and the last term are both perfect squares, and it's subtraction. So difference means we're subtracting. Even with a difference of squares, you still want to look for a greatest common factor first. So if you have two perfect squares and they're subtracted, it's going to factor a times a is a squared, c times c is c squared, and to get a negative c, you have to have one positive sign and one negative. So x squared minus 25, you look for the GCF first. There is nothing that they both have in common that I can pull out. They're both perfect squares and they're subtracted. So x times x is x squared, 5 times 5 is 25, one positive and one negative. On the next example, there's two terms, but the numbers are not perfect squares. So what am I going to do first? Well, before I even look for a difference of squares, I should be looking for the GCF. So 12x squared and 27 are both divisible by 3, leaving us with 4x squared minus 9. 4x squared is a perfect square, and 9 is a perfect square, and they're subtracted. So 4x squared is 2x times 2x, and then 3 times 3 is 9, one positive and one negative. Alright, when factoring trinomials, again, still, the first step is to always look for the GCF. So x squared, 3x, and 28. There's nothing that all three terms are divisible by. So the first times the first has to equal the first. So x times x is x squared. And then last times last has to equal the last. So there's different numbers that we can multiply to get 28. 1 times 28, 2 times 14, 4 times 7. So if I multiply 4 times 7, and then check that multiplication, so 4x and 7x, and I want that middle term to be 3x. So if the 4x was a negative, negative 4x plus 7x is 3x. and then I can check it by multiplying it back together. So x times x is x squared. X times 7 is 7x. Negative 4 times x. Negative 4 times 7 is negative 28. And that does give me back the original. So x minus 4 times x plus 7 is the factored form. On the next example, before I set up my two parentheses, I'm going to look for a greatest common factor. So notice that they all three have an x, and also they're divisible by 2. So the GCF is 2x, leaving me with x squared minus 3x minus 4. Notice that when I pull out a GCF, I don't lose it. It stays a factor in every step. So now I'm going to try to factor x squared minus 3x minus 4. So x times x is x squared. Last times last is 4, so I can multiply 1 times 4 or 2 times 2. So I want my middle term to be negative 3x. So if I do 1 times 4, 1 times x, 4 times x. If I have 1x minus 4x, that gives me a negative 3x. And then I can check it by multiplying it back together. So x plus 1 times x plus minus 4 is x squared minus 4x plus 1x minus 4. And then times your GCF times 2x. Distribute that through. 2x cubed minus 6x squared minus 8x gives me back the original problem. Alright, the next one. First, to look for a GCF, there's nothing that all three terms have in common. First times first has to equal first. So 2x times x is 2x squared. Last times last has to equal 9. So 1 times 9 or 3 times 3. Now remember, one of those numbers is going to get multiplied by 2. So if I try 3 times 3, then that gives me 3 times x is 3x, and 2x times 3 is 6x, and I need a 3x in the middle. So negative 3x plus 6x is 3x. And then you can multiply them back together to check. 2x times x is 2x squared. 2x times 3 is 6x. Negative 3 times x, negative 9. And it matches the original. Okay, the next one, 6x squared minus 16x plus 8. Notice that all of the numbers are even, so there's a GCF of 2. And then we can continue to factor. So first times first is going to be 3x squared. So 3x times x is 3x squared. Last times last is 4, so I can multiply 1 times 4 or 2 times 2. So this would be 1x and 12x, and I need my middle term to be negative 8. Well, 1x and 12x will not combine to negative 8, so we're going to try to switch these numbers. I can switch their order, 4 and 1. So this would give me 4x and 3x, which will also not combine to 8x. So we can try 2 times 2. So 2 times x is 2x. 3x times 2 is 6x. If I make them both negatives, negative 2x plus negative 6x is negative 8x. And then we'll multiply it all back together. So 3x times x is 3x squared minus 6x minus 2x plus 4. And then distribute the 2, 6x squared minus 16x plus 8. Matches the original. Alright, and then in Unit 6, we introduced the sum and difference of cubes. So the sum and difference of cubes are when there's, again, 2 terms, but instead of them being perfect squares, they're perfect cubes. And unlike squares, we only have a difference of squares. For cubes, we can factor sums and differences of cubes. So the first step never changes no matter what types of factoring you're using. The first step is always look for a GCF. So 125x cubed minus 8y cubed. Those don't have any factors in common that I can divide out. 125x cubed is a perfect cube. And 8y cubed is also a perfect cube. So you're going to have 2 factors. One's a binomial, the other is a trinomial. So the cube root of 125x cubed is 5x, and the cube root of 8y cubed is 2y. And then this first term is going to be this first term squared. So 5x times 5x is 25x squared. The middle term is going to be this term times this term, so 10xy. And then the last term is going to be this last term squared. So 2y times 2y is 4y squared. And then the sign is going to be the same sign, opposite, always positive. Okay, the next one, I have 2 terms. It's a sum. They're not perfect squares, they're not perfect cubes, but they do have factors in common. So both numbers are divisible by 3, and both terms have at least x squared. So we're going to pull out the GCF of 3x squared. That would give me 8 plus x cubed. Now 8 is a perfect cube, and x cubed is a perfect cube. So we're not going to lose our GCF. And then we're going to factor 8 plus x cubed. So the cube root of 8 is 2, and the cube root of x cubed is x. And then this first term is a first term squared. The middle term is going to be 2 times x. And then the last term is this last term squared. And then the same sign, opposite, always positive. All right, and then towards the end of Unit 6, we learned about dividing polynomials using synthetic division. So we're going to practice that. If I'm dividing by x minus 4, if I set x minus 4 equal to 0, x equals 4. So I'm going to divide by 4. And then I'm going to write just the coefficients. So 1 in front of the x squared, negative 6 in front of the x, and 1. Bring down the first term, multiply it by the outside, so 4 times 1 is 4, and then add that column, negative 6 plus 4 is negative 2. Multiply by the outside, 4 times negative 2 is negative 8, 1 minus 8 is negative 7. The last number is always your remainder, and then your constant and your x. So the quotient, or the answer to this division problem, is x minus 2 plus the remainder over what I divided by x minus 4. Alright, for the next one, I'm dividing by x minus 5. So set that equal to 0, x equals 5. And then before I write my coefficients, notice that this is not in standard form order. So we need to rewrite it as x to the third minus 2x squared. And then we're missing an x term, so plus 0x minus 75. So my coefficients will be 1, negative 2, 0, negative 75. So it is important that you check that what you're dividing by is always in standard form, that it's in order with from the highest exponent to the lowest, and also that there's not any missing terms. Any missing terms need to be filled in with zeros. So we'll bring down the first term, multiply, 5 times 1 is 5, add, negative 2 plus 5 is 3, multiply, 5 times 3 is 15, add it to 0, 5 times 15 is 75, negative 75 plus 75 is 0. That last term is your remainder, then constant x squared. So my quotient is going to be 1x squared plus 3x plus 15. If you have a remainder of 0, there's no need to write plus 0 over x minus 5.